Hello everyone, welcome to our basic algebra video. In this video, we are going to talk about some basic elements related to algebra before we get into slightly advanced topics like equations, inequalities, functions, etc. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you're watching this video in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of a course and also get to practice hundreds of questions after watching these videos. This would really help you to get a good practice and understand these concepts better. So let's get started. So first, let's understand what is a variable, right? The entire algebra as a subject or a domain is built on this concept of variable. So generally we get to see variables like x, y, z, k, a, b, c, mu, alpha, beta, Greek letters, the English letters. So what's the reason that we use any of these letters, right? So if I know an answer to a question, like let's assume that Ram has 10 apples and 20 oranges in his bag. If I ask you, so how many apples does Ram have in his bag? So you would say the answer is 10 because you know the answer for that. If I ask you number of oranges Ram has in his bag, you would say the answer is 20 if you know the answer. Let's say Ram has not given any information. You don't know how many apples and oranges he is carrying in his bag. So now let's assume that the same question has been asked. So can you tell me how many apples does Ram have? The answer is like unknown to me, right? I don't know. It could be anything. It could be 1, it could be 2, it could be 3. Similarly for oranges also, I don't know. So for that case, right, when I don't know this, I can actually take a variable in place of that, right? Let's assume, this is how we would have done in school when we first started algebra. Let's assume that number of apples is x. So this is just the alphabet which is basically replacing the actual number, that is 10. If I take that as a fact, because I don't know the number, I am putting a variable which is represented by a letter called x. You call them literals. So that's basically a label sort of it, which is saying, so if I know the value of x, that is the answer for the number of apples. Now there could be a clue that, for example, he purchased, right, apples by paying 100 rupees. Okay, so Ram purchased the apples he has by paying 100 rupees and cost of one apple is 10 rupees. With these two lines, I can actually figure out how many apples he must be carrying. Right? We obviously know, right? If one apple costs 10 rupees, so how many apples can someone buy with 100 rupees? So that's basically 10 apples. The other way to look at is this. So if Ram has x apples, each apple costs 10 rupees. So x apples basically cost 10x. Right? Each apple costs 10 rupees. So if I have x apples, if I say I purchased 5 apples, how much money would I have spent? Each apple costs 10 rupees, into 5 is 50 rupees. So instead of 5, I don't know, I'm putting with a variable x. So it's 10x. Right? And I know the total money is 100 rupees, right? Ram spent 100 rupees to buy 10 apples. So 10x is the money he would have spent. That is equals to 100. That gives me x as 10. That is the reason why we use the variables. The things which are not known to me, I will take as some variables like x, y, alpha, beta, any language, Greek, Latin, English, anything is fine. It's just that we are understanding that I don't know some value. This would be some number. Instead of that, I am putting some variable. Once I know this value, I can, do whatever I want. That is the purpose of this entire variables. The things that I don't know, I can actually find sometimes using additional information or clues. So to find that actual variable or the value, actually, let's say the number of apples is what I'm trying to find. I don't know this information, but I know this information. Okay, these are the additional clues. This I can solve by using the variable, I am assuming that unknown is x and I solve this. That is the entire purpose. The whole subject of algebra is built on this logic that I don't know something. I assume some variables that they are represented by some alphabets, English, Greek or anything, and then we solve as per the given additional information to figure out what is required by me. So algebraic expressions are built on the basics, that's variables. Like how alphabets are used to build words in English, and words are used, letters, right? Letters are used to build words, and words are used to build sentences and so on. Numbers and variables are used to build expressions, right? Algebraic expressions. So if I say there is an expression like 2x plus 7, this is an algebraic expression. I can also have something like 3x square minus 5x plus 6, or I can have something like 7x power 4 plus 8x cube plus 6 or something. All of these are the algebraic expressions. If you see this, there is a variable x here, and I can also have something like 6y square. It could be a mix of things. In this case, I have two variables, x and y. X as square, this x power 1 and y power 1. So I have power of 2, 1 and 1. For x power 4, x cube and y square. So the variables here, for example, in this case, I have used numbers 2 and 7, and I also have used a variable x. So using this as a combination, I built an expression 2x plus 7. These are called the algebraic expressions, right? So this could be in English translated like this. I don't know the number of apples, right? I am taking to be x, right? If I say that number of oranges he is carrying is 7 more than twice the number of apples. Twice the number of apples is this 2x. 7 more means plus 7. So 2x plus 7 could be the number of oranges. Right? Sometimes it can give a clue like that. So you will build the expression like this. Right? 2 into x, that's the number of twice the number of apples Ram has, 2x plus 7. 7 more than twice. So that's why it is 7 plus 2x. Right, so all the algebraic expressions are built using the numbers and variables, right? Add them, multiply them. Sometimes I can also have expression like 3xy plus 2x minus 6y square. What is this? 3xy is 3 into x into y plus 2 into x minus 6 into y into y. Right? That is what y square is, right? Y multiplied 2 times. So now let's try to understand the basic operations, right? Most of you would already know what to do with this, but some of the students I see struggle a bit. So I thought I'll just do these basics. You can skip or maybe move forward if you already know what to do. So this is things like this, right? Addition is one basic operation that you need to be able to do with some expressions. Like let's say I'm doing 2x plus 3y plus 4z plus x plus y plus 3z. What will be the final expression after I simplify? One thing you need to understand is this. What is 2x? It is like basically if I add x 2 times, I'll get 2 into x, right? That is what this basically means. So if I am adding 2x plus x, this should give me, this is like x is 1x. So 2 plus 1, 3x. And I won't add 2x plus 3y will not become 5y or 5x or something. This is wrong. These are two different variables. I cannot add them. I can only add, these are called coefficients. 2x, x is the variable and 2 is the coefficient. Right, so we only add the coefficients if the variables are same. So I'll add 2x and x. So 2x plus x is 3x. As I said, x means 1x, y means 1y. 3y plus 1y, that is 4y. 4z plus 3z is 7z. Right, that's how we add it. When it comes to subtraction, we do the same thing. I only subtract from the same variables. I would not do 4x minus 2y or something, right? So this expression would look like this: 4x plus 2y minus 3z. There's a minus for this entire expression, right? So plus z becomes minus 1z minus 2x. There is already minus here. Minus of minus is plus 2x. Minus 2y is minus of minus plus 2y. 4x plus 2x. So that's 4 plus 2x, right? That's 6x. Plus 2y plus 2y, so that's basically 2 plus 2y, so that is plus 4y. 3z minus 1, so if I write it, it will become minus 3 minus 1z, so it's minus 3 minus 1 is minus 4, so it will become minus 4z. So 6x plus 4y minus 4z. The subtraction is just like putting a minus sign, that's it, right? If I have an expression like 2x minus 2x, so this is 2 minus 2 into like x, so that's 0. 2x plus 2x will be 4x. And these are the basic things that you need to be able to do before you get into slightly advanced levels, right? So make sure you know these concepts well. Multiplication, like if I have to multiply this and this, so this will be done in this way. 2a square b is the expression into 3a. As I said, a square means a into b is a square b into 3 into a 2 into, right? 2a square b is 2 into a into b, 3 into a. So what I'll do is 2 into 3. I'll only multiply the numbers first. A is multiplied 3 times, so that's a cube into b. So this will become 6a cube b. Next I need to multiply 2a square b into 2b. That is 2a into b into 2 into b. So that's 2 into 2 is 4. A into a is a square, b into b is b square. So plus 4a square b square. I am just carrying this sign whatever I have here. Then I have minus 2. So that's basically 2 into a into b into 2 with a minus 2 if I want to put it like this. 2 into 2 is 4, a into a is a square and then b. So 4a square b and I need to put a minus sign. So the simple value is 6a cube b plus 4a square b square minus 4a square b. Now I cannot simplify further because you see this is a cube b. I don't have a cube b anywhere. This is a square b square and this is a square b. So they are all different. If I add, let's say, another expression like plus 6a square b, then yes, I can combine these two because a square b and a square b is common. But because I don't have anything, I cannot do anything further. Let's say I have a simple expression like this, x plus a into x plus b. What would this be? X into x, x square, x into b, so that is bx or xb, whatever the way, right? A into x is ax plus a into b is ab. Now you see x and x. So here a and b are constants, okay? They are not like they are numbers. It is like saying x plus 3 into x plus 4. Maybe let me do this. You'll otherwise get confused. There is only one variable x here. Similarly, I considered a and b are also numbers, x and y. X is the variable. X into x, x square, x into 4 is 4x, 3 into x is 3x, 4 into 3 is 12. So here I have to add both because 4x plus 3x will become 7x plus 12 and x square plus 7x plus 12. That's how you multiply expressions. Right? Then about the division part. So 12x square y cube plus 4x y cube plus 2xy minus 8x square y square divided by 2xy. You know, if you know the very basic concept of fractions, that is, if I say 5 plus 10 by 5, right? I know 5 plus 10 is 15 by 5 is 3. This is one way to do. Other way is, you know, this plus this by this can be broken into 5 by 5 plus 10 by 5. Right? So 5 ones are 5 twos are. So this will become 1 plus 2 equals to 3. You know, this is how I can break fractions. If I have something like 3 by 1 plus 2, this I cannot break as 3 by 1 plus 3 by 2. Okay, this is like absolutely wrong. Only numerators, yes, I can break them, and then same denominator I can keep doing it. Right? So similarly for this also I can do this as 12x square y cube by 2xy plus 4xy cube by 2xy plus 2xy by 2xy minus 8x square y square by xy. So as simple as it, how I multiply only numbers by numbers, I should also divide only numbers by numbers. 2 6 are 12. X square by x is like x square is x into x, right? So I am cancelling 1x. Y cube is y into y, so I am cancelling 1y. So y into y will become y square. So I'll get 6xy square. What about this? 2 1s are 2 2s are. X and x will get cancelled out. Y cube by y will be y square again, because y cube is 3 times y, so 1y will get cancelled out. So this will become plus 2 y square. 2 2 will get cancelled out. X will get cancelled out. Y will get cancelled out. So it's basically 1 is the remaining. So it's plus 1. 8x square y square by xy is like by 1xy 1 8. So it's as it is as 8x will cancel out square, y will cancel out square, so I'll have x and y left out, so it is minus 8xy. So this is the final answer after I divide it, right? So these are very fundamental and basic things. If by chance you are not clear with this, I strongly recommend you to solve some questions, right? Just search for the basic addition, multiplication of algebraic expressions and make sure you do more and get clarity on this. This is very important to be able to solve additional or maybe slightly advanced level, which is what you should be able to solve. If you struggle in this, there's a chance of struggling in those concepts as well. Not chance, you will definitely struggle in that. So I strongly recommend, if you are not doing good for some reason in these basics, you're not getting this correct, then please make sure that you search for some questions online for basic algebraic expression, addition, subtraction, division, multiplication, and keep doing them, maybe 10-20 questions, and then you'll get used to this. So then there is these algebraic formulas that will be really helpful for you to solve many problems. So this, all of us would have started with the very basic formula. What is a plus b whole square? That's a square plus b square plus 2ab. If I ask you what is x plus 6 whole square, what would this be? X square plus 6 square plus 2 into x into 6. So that is x square plus 36 plus 12x. Right? So a minus b whole square is a square plus b square minus 2ab. Right? Then a plus b whole cube. So that is a square, sorry, it's a cube plus b cube plus 3a square b plus 3ab square. You know, that goes like this: 3a into b plus 3 into a into b into b. So if you are confused, right, you see this formulas are set in such a way that a square power is 2, b square the power is 2, a power 1, b power 1, so 1 1, that's again sum is 2. Right, that's why you'll have always a power of 2 in this expression. Similarly, for a plus b whole cube, it's a cube plus b cube plus 3 into a square b power 1. So 2 plus 1 is again 3 power. 1 plus 2, the power is again 3. This is 3 and this is 3. Right, and you'll only see the coefficients also as 3 and 3. Similarly, a square plus b square plus 2ab also has 2 and 2. It doesn't necessarily mean that a plus b whole power 4 is a power 4 plus b power 4 plus 4a cube b plus 4ab cube. Okay, if you're thinking this could be wrong, I would definitely say this is wrong. I don't go with this mindset. The way you should do this is first do a plus b whole square, then do square, and then you'll get the answer for that. Anyways, but just I'm giving you this if you are confused, if you ever feel that you forget the formulas, right? So it should be a cube plus b cube, because it's whole power 3, so it's a cube plus b cube plus 3a square b. So the coefficient will be 3 and also a square b power 1, so that sum is 3, and 3ab square. A minus b whole cube is a cube minus b cube minus 3a square b plus 3ab square. And a plus b plus c whole square is like I have 3 terms here. So this will come as a square plus b square plus c square plus 2ab plus 2bc and 2ca. Similar to this, like a square plus b square plus 2ab. But then I also have b square plus c square plus 2bc, a square plus c square plus 2ca. That's how you have to remember this, but these are important formulas to remember. Then a square minus b square is written as a minus b into a plus b. Right, this is into. A cube minus b cube is written as a minus b into a square plus b square plus ab. And a cube plus b cube is written as a plus b into a square plus b square minus ab. You see, this is minus I am seeing here, and then I have a plus here. When it comes to a cube plus b cube, I have a plus here and then I have a minus here. Right? Minus becomes plus, plus becomes minus. So that's small difference. You have to be careful on the formulas again. A power 4 minus b power 4 is basically written as a square minus b square into a square plus b square. Right? This is done by using this one. What is a power 4 minus b power 4? It can be written as a square square minus b square square. Now this will become like this. So I will write a square minus b square into a square plus b square. Again, a square minus b square is split into a minus b into a plus b. So you'll have a minus b into a plus b into a square plus b square. If you see a square minus b square, a power 4 minus b power 4, a cube minus b power b cube, always a minus b is one of the factor, right? So that will be a useful point to use. Even if I say a power 71 minus b power 71, I don't know what will be the remaining expression. Definitely I will have a minus b into something. It could be anything, it will always work. but might not be the case for plus sign. It's not a cube plus b cube is not always a plus b into something. It might be different. You just have to be careful on that. But keep just these formulas at least in mind, right? These are like most used and relevant formulas if you ask me with respect to the problems. A cube plus b cube plus c cube minus 3abc equals to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So all of these expressions are standard expressions which are used in one way or the other in some questions. So good to keep in memory. The more you understand the conceptual in way, so that you can actually even do for higher levels, right? I said how we can do for a square a plus b whole power 4. You do a plus b whole square, so that is a square plus b square plus 2ab whole square, and this is like a, b and c. You have to use this formula to expand and get a complicated thing, but that's how you can actually do it and derive if there is any requirement for that. Like also I said you don't need to remember this. If you understand a square minus b square is so and so, you can do in this way: a square minus b square into a square plus b square. Again, this is expanded as a minus b into a plus b. Right, but these are very useful formulas. Just make sure that you keep them in your memory and sort of revise if it's required. So next, sometimes you'll get to see concept called factorization, right? That is, if I'm talking about this, factorize x square minus 3x minus 28. Factorization is like this in numbers. If I'm asking to write factor 24, it's like writing 8 into 3 or 12 into 2. Like product of multiple numbers is like basically writing as factors. So similarly, factorizing this is also something like I need to write some expression into some expression, maybe into some. Because it's a quadratic, I generally would get only 2. If it's a cubic, I will get 3. That's how we can sort of understand. So how do I factorize it? At x square minus 3x minus 28. So this is something that we'll discuss in depth in quadratic equations in the equations video, but just to show even if it's confusing for now, don't worry. If you move ahead and look at the equations, the quadratic equations part in the series, you'll get a good understanding of how to solve this. So this, the way I would look is this. So 7 into 4 is 28. This is the way you have to do. Always look at this constant. If this is 1, if there is something coefficient for this also, make sure you multiply both this and this, and then try to split into 2 factors so that they can be summed up to get whatever I have here, right? So what is this? Minus 28, right? 1 into minus 28. So if I split as minus 7 and 4, minus 7 plus 4 is minus 3. So basically I can write this as x square minus 7x plus 4x minus 28. What is minus 7x plus 4x? It's minus 3x. So x square minus 7x plus 4x minus 28 is the same expression. Now if I take x common here, right, for these two, x into x is x square minus 7, right? So x into x is x square, x into minus 7 is minus 7x. Plus I take 4 common, 4 into x minus 4 into 7. Now I have x minus 7 common, so I'll take x minus 7 common, I'll get x plus 4. Right, so the factorizing of this is x minus 7 into x plus 4. That's how you do for a quadratic. Slightly higher powers could also be done in the similar way. We'll show with maybe some examples, some problems. But this is good enough. If you know how to do quadratic, that's generally mostly required. Beyond that, it's very rare to be seen. But what's the remainder when x square minus 3x minus 28 is divided by x minus 7? So I can do this similar to how we divide. So x minus 7, like how we do, if I say if 24 is divided by 7, what is the remainder? So we do this way, right? 7 3 is at 21, so 3 is left out, so 3 is the remainder. Similarly, I can also do for this. So what will I divide with? I'll divide with x first. X into x is x square. X into minus 7 is minus 7x. Automatically I'll get minus and this will become plus. Right? I was doing the same, right? 24 minus 21 is the 3. So I'll have minus, so minus plus becomes minus and minus becomes plus. So this gets cancelled out. Plus 7x minus 3x is 4x. Automatically this will follow 4x minus 28. Right? Then I will do plus 4. So that 4 into x is 4x. Minus 4 into minus 7 is minus 28. So it's minus plus. So the remainder is 0. So that's why the answer is remainder is 0. So doing this is definitely a bit complicated and a bit more time taking. The easier method, when you see question like this, find the remainder when some expression is divided by x minus something. Just understand, if I substitute x is equals to 7, how did I get x is equals to 7? I just equated x minus 7 equals to 0. So I get x is equals to 7. I'll substitute this value in this expression. Whatever I get is the remainder. So 7 in here is 7 square minus 3 into 7 minus 28. So 7 square is 49, 3 7s are 21 minus 28. So minus 21 minus 28 is also 49. So 49 minus 49 equals to 0. So the remainder is 0. Similarly, let's look at this question. Find the remainder when x square minus 3x minus 28 is divided by x minus 2. So I'll do x minus 2 equals to 0. So x is equals to 2 is what I need to substitute. So 2 square minus 3 into 2 minus 28. So that's 4 minus 6 minus 28. So this will come as minus 30. So the remainder when x minus 2 is divided by x square minus 3x minus 28 is minus 30. Right. So maybe let me just do one thing. I'll just do this division to just show that's the correct remainder that you get if we do the way that I was discussing earlier, the normal division method. X minus 2, x square minus 3x minus 28. So I'll first divide with x so that I get x square minus 2x. So it will become minus and plus. So will get cancelled out. Plus 2x minus x is minus x minus 28. Right. So I'll just do with minus 1. So x into minus 1 is minus x, minus 1 into minus 2 is plus 2, so it will become minus becomes plus and plus becomes minus, they get cancelled out. Minus 28 minus 2 is minus 30. That's the remainder which I got, right? That's how you can simply calculate by just substituting this than rather doing this method. This is the easier and faster method. No way that you'll get it wrong if you are good with normal addition subtraction. This might take a bit more time and might be difficult as well depending on your comfort zone. So stick to this for the remainder. We can use the similar logic for the factorization also, right? So that is like if I know 7 is one of the factor which gives a remainder 0. So once I know that, then I can try to split it in this way. I'll show you in another example where that would be helpful for a cubic or higher powers. So for the quadratic this is good enough. If not, we'll give you another format of finding the roots by using formulas minus b plus or minus b square minus 4ac by 2a. We'll come to talk about that in the equations part, so don't worry. Then you need to know some basic exponents. So what is exponent? What do I mean by 2 power 3? Basically 2 multiplied 3 times. Right, 2 into 2 into 2. Right, if I say 4 power 5, it is 4 multiplied 5 times. Right, so some number or variable raised to a power, that's called exponent. So we have some basic formulas that would help you to do the operations faster and easier. So if I ask you what is 2 power 3 into 2 power 5, this is 2 power 3 plus 5. That is x power a into x power b is x power a plus b. So that is 2 power 8. The base should be same. If I have something like 2 power 5 into 3 power 3, it's not 2 power 5 plus 3 or 3 power 5 plus 3 or something. The base should be same. Then 1 by x power a can be written as x power minus a. That is, if I say 1 by 2 cube, right, that can be written as 2 power minus 3. Right, and then x power a by x power b is written as x power a minus b. That is, if I say, let's say 2 power 5 by 2 power 3. What is this? 2 is multiplied 5 times. 2 is multiplied 3 times in the denominator. So I'll cancel out 3 2's. So I am left with 2 square, which is what I can simply do 2 power 5 minus 3. That is 2 power 2. Right, which is what I did after calculations, right? So that's why x power a by x power b can be written as x power a minus b. Multiplying this x power a into x power b, it will become x power a plus b. If I am dividing, it will become x power a minus b. X power a whole power b can be written as x power ab. So that is, if I say 2 cube whole power 2 can be written as 2 power 3 into 2, that is 2 power 6. What is 2 cube? 8. 8 square is 64. What is 2 power 6? 64. So this is correct, right? So I can use this formula, x power a whole power b is this. See, sometimes you will see things like 2 power 3 power 2. This is not 2 power 6. This is 2 power 3 power 2. I am doing the power to 3. So this is 2 power 3 square, that is 2 power 9. This is different from 2 power 3 whole power 2. This 2 power is for the entire expression. So that's why this can be written as 2 power 3 into 2, that is 2 power 6. Any number raised to 0 is 1. 2 power 0, 5 power 0, 10 power 0, doesn't matter. It is always 1. And x power 1 by a is 8th root of x. So what do I mean by that? So if I have number like 64 whole power 1 by 2, this is basically square root of 64, that is 8. You can technically say it plus or minus 8 to be frank. Even minus square root of 64 can be minus 8 as well. Or if I say 64 whole power 1 by 3, that is cubed root of 64. Cubed root is coming because it's 3, square root is coming because this is 2. So cubed root of 64 is 4. That's 4 cube is 64, so cubed root of 64 is 4. So x power 1 by a is written as 8th root of x. Then if I have x power b by a, right? So x power b by a is like this, right? X power b into 1 by a. So this can be written as x power b whole power 1 by a, or I can write as x power 1 by a whole power b. Using that I will get this, right? X power a whole power b is multiplication of both powers. So I can write x power b whole power 1 by a or x power 1 by a whole power b. Right? If I ever get to see a question like 81, maybe let's say 729 whole power 3 by 2. In this case, if I have to simplify this, doing like this 729 whole power 3 power 1 by 2 is really difficult. Finding the cube of this number, which is already large enough, and then doing this is really painful. Right? Rather, I can do 729 whole power 1 by 2 power 3. This is square root of 729 is 27. 27 power 3 is relatively easy to find out. Right? Still, it's not that easy, I agree. Maybe the numbers could have been slightly easy, but I'm just saying which formula would help me better would depend on the situation. That's why good to know that you can play around with that. Right, so let's solve some problems. As we always recommend, we ask you to pause the video, try these questions on your own, then follow with our explanation, right, and learn the concept if you missed something. Hope you have passed. So find the factors of x square minus 4x plus 3. So let's do a quadratic again. X square minus 4x plus 3. So I'll just give you the way that I am gonna use, which will be useful for higher powers also. When you see expression like this, see what is the coefficient of the higher power and see the number 3 here. So this is 1, right? So it's basically 3 into 1 is 3. Now list the factors for 3. This is 1 and 3 are the only factors, right? So that means just make sure that you check that x is equals to 1, x is equals to 3 as the potential, actually plus or minus should be the right one, but you should check with the plus 1, minus 1, plus 3, minus 3. Out of these 4, one of them would definitely be the root for this. Once I know it, I can actually go ahead and solve it. So how do I check if it's root or not? Just substitute x is equals to 1 into this expression. 1 square minus 4 plus 3. 4 into 1 is 4, so this is 0, so that means this is a root. So that solved my question. So that means x square minus 4x plus 3 would be looking like x minus 1, because x is equals to 1 is the root, so that means I will get x minus 1 into I'll have some expression. Right, now I need to find this out. For this I can use the division concept which I've talked about earlier. So x square minus x minus plus cancel out, minus 4x plus x is minus 3x plus 3. So minus 3. So it will be minus 3x plus 3. So minus becomes plus and this becomes minus, cancel and 0. So x minus 3 would be it. So this is x minus 1 into x minus 3. Right? This expression can be written as x minus 1 into x minus 3. The other way, if you can actually look at it carefully and sort of split this, right? X minus 1 is a root, so I just need to do like this. X square minus x, so that I take x common, I get x minus 1, right? So if I take minus x, what is remaining in minus 4x? It's minus 3x plus 3, right? If I take minus 3, I'll get x minus 1. So now I'll get x minus 1 into x minus 3. This is also another way for you to actually split and get them as factors. But all of this happens only when you're clear with your fundamental concepts, right? So whatever method suits you, you can do it. And there's also a roots formula minus b plus or minus, which would give you the roots as 1 and 3. Once you find out both the roots, you can write a quadratic equation as x minus 1 into x minus 3. all of these things will work for a quadratic. We'll anyway discuss in depth in the equations part. So don't worry if it's not completely clear. It should be clear to a good extent, but let's say you're not completely clear. So we'll discuss about that again in the quadratic. Right, now let's look at the higher power. Right, that's the cubic thing which I was talking about. This would be a little bit more complex, and it will only be possible if you actually are clear with what we have done in quadratic. So yeah, x cube minus 2x minus 5x plus 6. As I said, look at the corners 6 and 1. So that's basically product is 1 into 6 is 6. So if I write factors of it, 1 6 are 6, 3 2s are. So I just need to be careful with only these values, right? Plus 1 minus 1 plus 3 minus 3. So let me just substitute plus 1 into this expression. What do I get if x is 1? 1 cube minus 2 minus 5 plus 6. This is also again 0. If let's say it's not coming to be 0, that is not root, then you need to try for minus 1, try for 3, minus 3, keep doing till you get one of them as the root. Every time I've been lucky that I'm getting the first one itself the root. 1 plus 6, 7 minus 7 is 0. So x minus 1 is a factor. Into I should be getting a quadratic expression because it's the cubic, right? So I should have x minus 1 into some quadratic expression. So again do this division thing, right? So that you actually can find out the remaining expression. So let me do this division. So how would I do? X minus 1, x cube minus 2x minus 5x plus 6. Right? So I divide with x, multiply with x. So x square becomes x cube, x square into x minus x square. Right? They get cancelled out. That's minus and this becomes plus. But I don't have x square here. So I'll carry forward x square and also I need to carry minus 2x. Right? So it becomes x square minus 2x. Now I will multiply with x so that x into x is x square and minus x is what I get. So this become minus and plus, they get cancelled out. Minus 2x plus x is minus x and minus 5x is also carried like down. Sorry, this is 2x square, right? My bad. I did a mistake here. My bad. Sorry. I forgot that part. So that's going to give me the wrong answer. So let me do this. X cube. So x square. X cube minus x square, so it's from plus minus 2x square plus x square means it is minus x square minus 5x will be carried forward down. So then I need to multiply with minus x so that I get minus x square and then plus x. So minus x square will become plus and this will become minus. They both cancelled out. Minus 5x minus x is minus 6x plus 6. So I just need to have minus 6, right? Minus 6 into x is minus 6x. Minus 1 into minus 6 is plus 6. So this will become plus and this will become minus, cancel out and that's it. So that means I can write x cube minus 2x square minus 5x plus 6 as x minus 1 into x square minus x minus 6. Now from here I need to again split them, right? So as I said, the roots for this would be slightly different. So I have 1 here and 6 here. So minus 6 is the product. So it could be 3 and 2. Minus 3 and 2, etc, etc. I guess minus 3 and 2 will work here because I have minus x. So we get x is equals to 3 as one of the roots, so I satisfy it, right? 3 square 9, minus 3 minus 6 is 0. So x minus 3 is one of the factor for this. X square minus x minus 6. I can again do x minus 3, I divide this expression x minus 3 x square minus x minus 6. This is tedious approach, but this is only required when you are not able to do basic factoring for a quadratic and figure out the roots for it so that you can write them as. So this will become x minus 1 into x minus 3 into x plus 2. So sorry, x plus 3 and x minus 2, my bad. So it is minus 3x plus 2. So x minus 3 and plus 2, sorry, yeah. X minus 1 into x minus 3 into x plus 2 is the expression that you will get for this entire expression. Right? So this is definitely a longer approach and takes a bit of effort, but this is the way that you have to do for higher powers whenever you get to factorize. The chance of seeing this is very low because that's definitely on the harder side. So now let's look at the next one. Find the remainder when x cube minus 2x minus 5x is divided by x minus 5. So as I said, the simplest way is to only just substitute x minus 5, right? So when divided by x minus 5, so take x is equals to 5, put it here, 5 cube minus 2 into 5 square minus 5 into 5 plus 6. So it's 125 minus 50 minus 25 plus 6, 131 minus 75. So that is 56. The answer is the remainder is 56 when this x cube minus 2x square minus 5x plus 6 is divided by x minus 5. As simple as it. So that's why it's better to do this than doing the division and getting the 56 part. So if x plus 1 by x is 4, find the value of x square plus 1 by x square and x cube plus 1 by x cube. So whenever you see like this, x plus 1 by x or x minus 1 by x and then x square, x cube, etc. Don't try to find what is the value of x or trying to quadratic equation, solving an equation like that. If you have an idea of how to go about making it a quadratic equation, the simpler one is using the algebraic formulas like a plus b whole square. What is this? If I expand x plus 1 by x equals to 4, x plus 1 by x, if I square on both sides, this will be like this, right? This will be x square plus 1 by x square plus 2 into x into 1 by x. They get cancelled out. So x square plus 1 by x square plus 2, 4 square is 16. So I send 2 here, 16 minus 2 is 14. So x square plus 1 by x square is it's 14. Right? That's what this is. So if I am talking about x cube plus 1 by x cube, all you need to do is to do a plus b whole cube. Is a cube plus b cube plus 3ab square, 3a square b plus 3ab square. So what is a cube? X cube plus 1 by x cube plus 3 into x square into 1 by x plus 3 into x into 1 by x square. Right? X cube plus 1 by x cube plus, I'll cancel this and this, so I'll get 3x plus, I cancel this, so I'll get 3 by x. What is this? A plus b is 4. So I'm squaring on both sides. So this will be 4 cube. This is 64. Now what should I do? I have to find out this. Now I have to find some value for this. So if I take 3 common here, I'll get 3 into x plus 1 by x, right? X cube plus 1 by x cube plus 3 into x plus 1 by x is 64. And I know x plus 1 by x is 4. So 64 is equals to x cube plus 1 by x cube plus 3 into this entire x plus 1 by x is 4. So I'll get 12. So 12 goes this side. I get x cube plus 1 by x cube is 64 minus 12 and that will be 52. The answer is 52 for this. Right, this is 52 and this is 14. All I did is just a plus b whole square and a plus b whole cube. The reason why they give x plus 1 by x is for this advantage of cancelling out x into 1 by x and x into 1 by x, right? That's why you will see questions like this. That's why you have to solve them. If I ask you about x power 4 plus 1 by x power 4, first you need to find this. Now if I do squaring for this, right, what do I get? X power 4 plus 1 by x power 4 plus 2 into x square into 1 by x square, they get cancelled out. 14 square is 196, 2 goes this side, is 194 is the value for x power 4 plus 1 by x power 4. And that's how you solve them. So these questions are basic questions testing your concepts of exponents. 2 root 2 into 64 square is 34 into 4 power a, find the value of a. So if you know this point, right, 2 power 16 is 2 power a, so what is the value of a? It's 16, right? The powers, the exponents have to be same if the bases are same and they are equal to as a whole value. So 2 power 16 is 2 power a has to be 16. So I need to do the same thing so that I get entire thing equals to same base with some powers so that I can find the value of a. So let's say I see 2, right? So let me convert everything into 2. What is 2 root 2? 2 into root 2 into 64 square is 32 into 4 power a. So 2 is 2 power 1. Root 2 is, as I said, 2 power 1 by 2. 64 is 2 power 6 power 2. 32 is 2 power 5. 4 is 2 power 2 power a. So if I x power a into x power b into x power c, first let me say this, 2 power 6 power 2 will be 2 power 6 into 2. That is 2 power 12 into 2 power 1 by 2 into 2. So this is 2 power 1. So this, the base is same. So it is simply ending to be like this. That means 12 plus 1, 13 plus 1 by 2 is 27 by 2. And this will be 2 power 5 into 2 power 2 power a is 2 power 2 into a. That is 2 power 2a, 2 power 5. So equals to 2 power 5 plus 2a. So finally the powers have to be equated. So 27 by 2 is 5 plus 2a. Right, 5 goes this side. So 27 by 2 minus 5 is 2a. So 2 5 are 10. 27 minus 10 is 17 by 2 is 2a. And a is 17 by 4, which is like 4.25. I have to write in decimals. But anyways, this is how we have to do, right? Basically the goal should be getting all to the same basis, right? To the 2 and 2. I see everything here which can be converted into 2. If I had an expression like into 9, I couldn't have solved this question. They would not give you a question like that, right? They would give you such a way that all of them could be brought to a common base so that I can equate the exponents and get something. Now arrange the following in ascending order. So I just need to make sure which one is the largest of the lot and the smallest and the middle one according to this. As I said again, when I have to compare things, it's good to get to a common base and then see the powers. If the powers are same, see what is the coefficient in between them. What I am talking is this, 2 power 3 versus 2 power 5. It's clear that 2 power 5 is greater than 2 power 3. Right? If I say 2 power 4, 2 power 4, if I have 3 into 2 power 4 and this is 4 into 2 power 4, 4 into 2 power 4 is greater than 3 into 2 power 4. So that is what you need to try to equate, get this. If I see all of them 81, 9, 3, 27, 81, all of them are powers of 3. So let me try to get all of them to common thing. What is 81? 3 power 4 power 50 and 1 by 9 is 3 square, right? 1 by 3 square. 3 power 4 power 50 is 3 power 4 into 50 by 3 square. So 3 power 200 by 3 power 2. So this can be written as x power a by x power b is x power a minus b. So this is 3 power 198. This entire expression will come to be 3 power 198. Right? This is directly written as 3 power 234. I know that 3 power 234 is greater than 3 power 198. Now let me check this one. 27 is 3 power 3 power 67 into 81 is 3 power 4 power 21. So 3 power 3 power 67 is 3 power 3 into 67 and 3 power 4 power 21 is 4 into 21. So 3 into 67 will be 201. So 3 power 201 is this into 3 power 84. So this is 3 power x power a into x power b is x power a plus b. So this will come as 3 power 285. So this is the largest, this is the second largest and this is the smallest. So they are already in a sort of ascending order. Smallest, next the largest and larger and the largest of the lot. Right? That's how you have to compare, sort of play around with the exponents. So that's it for the basics of algebra. Right? We strongly recommend that you have to be very comfortable with whatever we have dealt in this entire thing. Maybe you could be struggling a bit with the factoring, x cubes, x4s, x power 4s, or maybe even quadratic expression, how to factor it faster. But you should be able to factor it in a decent way. These are the basic things that you need to be able to do so that you can handle the equations or inequalities or basics of functions, etc. So anything slightly advanced in algebra requires you to be comfortable with all of these basics. Right? So we strongly recommend you to watch this video completely. If you have doubts, check those parts again. If you're watching this YouTube, we recommend you to go to the store, gtcube.com/store, in our partners website, where you'll find these videos along with practice questions, where you'll get to practice some questions after this video. If you register for that course, which is available for free, you would be able to actually get the practice and would help you to actually understand these concepts better, so that you can move ahead and look at the advanced concepts. Also do like our partners Facebook page, facebook.com/gtcube3, We're coming up with a lot of content for various exams. You'll get all those notifications, updates shared over there. So don't miss them. So thank you for watching this video, and let's meet in the next video.